When you solve a linear system, what you are actually doing is you're looking for the point where they intersect if you were to graph them, because that point represents an x and a y value that make both equations true. But sometimes we have systems that run parallel, the lines are parallel when you graph them, or they're the exact same line. So most of the time when we solve a linear system, the two lines on a graph would intersect, and where they intersect, the x and y value is a solution. But if they run parallel to each other, and remember parallel lines have the same slope, if they run parallel to each other, that means there is no solution because there's no intersection point. And if the two lines end up being the exact same thing when you put them in slope-intercept form, that means they're going to have infinitely many solutions because every point on the line is going to be a solution of both equations. So let's look at an example. This says show that this linear system has no solution. Now if you're looking at both of these, we have our three ways to solve them. We can graph it, we can use substitution, or we can use linear combinations. Let's just say, for an example, that I wanted to graph both of these. To graph these, the easiest method is to put them in slope-intercept form. So if I put this in slope-intercept form, I add 6x to both sides. And then I will end up dividing each side by 2. And we have y equals, if I divide 8 by 2, I get 4. If I divide 6 by 2, I get 3x. Now we can look at our other equations here. Again, I'm going to put them in slope-intercept form so I can graph them. And I'll show you how we could use substitution too. Okay, again, y equals mx plus b, so I'm going to add a 3x to each side. Left with y equals 7 plus 3x. Now what I want you to notice right here is, remember, our coefficient of x is our slope. Notice that both of these equations have the exact same slope. When they have the same slope, it means they're parallel. And so at this point, I could just go no further and just say that there's going to be no solution. There is no x or y value that is going to make both of these equations true. But if we wanted to graph these, let me show you. If we graph the first one here, 4 plus 3x, my y-intercept is 4, and my slope is 3 over 1. So I'm going to rise 3 and run 1. Okay, and then our other one had a y-intercept of 7, and again the slope of 3. So that's 4, 5, 6, 7. Our slope of 3 means we rise 3 and run 1. Again, when you graph this line, you're going to see that these two lines in blue and green here run parallel to each other and are never going to intersect. Oops. We wouldn't have to do that if you recognize, if I can get my line to work here, if you recognize that they have the same slope. Because graphs that have the same slope are going to be parallel and they're never going to intersect. So you don't necessarily have to graph it, but once you get to the graph, if you get something where they're running parallel, you're going to have no solution for your answer. Now let's say you chose a different way to solve. Let's say if you recognize here that it'd be pretty easy to solve for y, we could use substitution. So you just add 3x to each side, just like we just did actually. And we get y equals 7 plus 3x. We can substitute that now in for y in this equation. Again, now we're just using a different method. We're using substitution. So I'm going to say negative 6x plus 2 times my y, but my y is 7 plus 3x. and that's going to equal a negative 8. Now let's see, when we solve this, we use our distributive property and then gather our like terms. So we have a negative 6x plus 2 times 7, which is 14, plus 2 times 3x, which is, 6x, and then gather your like terms. Negative 6x's and a positive 6x's are actually going to cancel out to give you 0x's, so we're left with 14 equals negative 8. That is not a true statement. So if you were to solve a linear system by substitution and you get a statement that is not true, 14 does not equal negative 8, then you'd also say that there is no solution. So there's different ways you can see it. You can see it if they have the same slope and then put it on a graph. You could even see it. Or if you come up with an untrue statement, that means there's no solution. Even the same would be true with linear combinations. You come up with an untrue statement. So it is possible, even though we've been working mostly with lines intersecting, there's one solution. It is possible for there to have no solution, and as you'll see later, infinitely many solutions.